So section 4.5, which is the last section in the course, is called integration by substitution. And integration by substitution is generally the first really interesting antiderivative technique that a student learns. And it's going to be the only really interesting antiderivative technique that we're going to learn in this course. The rest are going to be deferred to Calculus 2 for those of you moving on to Calculus 2, for those of you that need more of a background in calculus than Calculus 1 alone can provide. And I wanted to get an idea for what integration by substitution is all about by looking at this problem. So remember, we're trying to take the antiderivative of this expression right here. Now, at first glance, it looks like kind of a complicated expression. So f prime is cosine of x squared plus 3x plus 1. I'm going to put that all in parentheses, followed by 2x plus 3. And we're looking at that, and what we want is the original function f. And I don't know if just looking at this you can guess what the original function f is. It sort of depends on whether you have the right insight as to what rule was used to take the derivative. If, in case that's not coming clear, and you can always pause the video and think this over for as long as you want, but in case you've done that and it's still not coming clear, let me just remind you of the chain rule. So remember, if we have a function g of h of x, so you have an outside function g and an inside function h, and we want to take the derivative of that whole thing, what you do is you take the derivative of the outside part, you write the inside part exactly as it is, so g prime of h of x, and then you multiply by the derivative of the inside part. So you take the derivative of the outside part, put in the inside part exactly as it is, and then you multiply by the derivative of the inside part, and that's the chain rule. So if we're looking at this thing and we think, oh, wait a minute, it kind of looks like somebody used the chain rule on this, because 2x plus 3, well, that's just the derivative of this thing. So the inside part must have just been x squared plus 3x plus 1. So let's put that in. X squared plus 3x plus 1. And over here, I took the derivative of the outside part. So cos of something is a derivative of what? Well, it's a derivative of sine of something. So I'm claiming that a perfectly nice antiderivative for cos x squared plus 3x plus 1, that whole thing multiplied by 2x plus 3 is sine of x squared plus 3x plus 1. Let's just double check. So let's just take the derivative of f of x and see what we get. We're going to use the chain rule. Derivative of sine is cosine. You write the inside exactly as it is, x squared plus 3x plus 1. And then you go ahead and you multiply by the derivative of the inside part. Well, that's easy. Derivative of x squared is 2x. Derivative of 3x is just 3. Don't forget to put that in parentheses so that the multiplication happens before the addition. That the addition happens before the multiplication. We definitely want 2x plus 3, all of that to be multiplied by this. But anyway, you can see that this looks exactly like what we just have here. So the antiderivative of cosine of x squared plus 3x plus 1, all of that times 2x plus 3 is equal to sine of x squared plus 3x plus 1 plus a constant. All we did is we spotted that this was a derivative taken using the chain rule. And that is the essence of integration by substitution. Integration by substitution is an algebraic technique that will allow us to spot this in more complicated situations.